Hello, everyone. I'm Amparo Alvarez. I'm an industrial designer and I'm a research professor and specialist in strategic design at Pontifical University of Ecuador, which is a private institution. I'm glad and grateful to have the opportunity to present here my contribution titled Stakeholders in Active Pedagogical Approach Developing Specific Professional Skills for Design Management. The results of my research, which I will present today, were initiated by a concern about how theoretical subject of design management can significantly contribute to developing professional skills and closer with industry. Universities are constantly seeking to adapt teaching and learning methodologies with industrial and professional reality. However, the industry is one of the fastest developing sectors, which requires universities to remain close to industry and to propose increasingly innovative pedagogical processes. This means a faster obsolescence of learning models that develop professional skills in students. This goal implies a greater involvement of external stakeholders in the teaching process by establishing industry-specific roles and different kinds of participation. This relationship would favor constant feedback and more intimate involvement in the pedagogical strategies proposed by the teacher to develop the design manager's professional skills. So, in study, I was looking for pedagogical strategies and learning orientations that link university and industry. Doing literature review, there are some factors that I analyzed, and I was going to go a bit deeper into each of them. First is industry-oriented learning. This learning orientation is linked to the transfer of theoretical knowledge from the university and practical knowledge from industry. It focuses on creating a continuous technical and business learning approach to linking students in practical practice with the industry. This approach assumes that disruptive learning creates disruptive spaces to develop professional skills, training, and job opportunities. On the other hand, this learning orientation proposes linking industry directly to practice. This proposal suggests developing professional skills based on the logic of the internal running of a business logic. Interestingly, this model is an industry-led student approach to real work, joined to a constant assessment process of learning in the university by providing inputs and outputs oriented to value the competence of specific attitudes and knowledge as a criteria for effective professional practice. We know that industry-oriented learning necessarily creates a symbiotic ecosystem between higher education and the productive dynamics of industry. Sustainably maintaining this relationship involves establishing common goals, focusing on real-world problems and technological advances in terms of innovation and current industrial demands. From an educational approach, this partnership requires leadership from the universities. Dynamic learning experiences are proposed to ensure that students' learning outcomes and profile graduation are met. So, proposing a stakeholder-based learning ecosystem between industry, academia, and the state, as proposed in this triple helix model, requires strong communication and strategies to strengthen knowledge integration. This perspective explicitly places the industry in the more intimate relationship with academia. From a practical approach, this intimate relationship proposes adopting a pivotal role for industry, including it as a dynamic actor in the learning strategies applied within the classroom and mediated by the professor. This proposal facilitates the transfer of knowledge from work situations from an operational perspective in the company to the transition between theoretical knowledge and the exercise of professional skills from current professional practice. This objective fundamentally requires the incorporation of competency-based learning on pedagogical approaches that develop complex specific skills so the students manage their knowledge and can adapt to real working environments and complex situations. Based on this case study, design management is a business-oriented discipline that promotes innovation based on elements that identify and describe organizational culture. In this sense, the product design course offers the subject of design management to enable the students to solve business problems, promote an understanding of an industry's dynamics, contribute to value change by expanding products and services, and create a sustainable innovation. This purpose requires developing soft skills for design management as well, such as collaboration, communication and facilitation, time management, critical and creative thinking, context mastery, and reflection in on action. This study evaluated whether professional design manager skills are developed after the experimental exercise linking businesses with groups of students in co-creation and feedback processes. Over the course of a year, a group of students made a rapid diagnostic process in design management. This practical exercise was designed to uncover how companies respond to environmental changes, intending to identify opportunities for developing new products and services. 17 fourth-level students and 7 case studies from manufacturing business participate in this exercise. A training of trainers model workshop was held in which the students were trained to play the role of mediator and guide with company's team of workers. The process was developed over 4 consecutive months, in which several working meetings were organized with a team of approximately 3 to 5 people per business. The sessions lasted approximately 2 hours. Then the students used open educational resources, tools to face-to-face and hybrid sessions based on mutual agreement between the team of students and the businesses. Before starting the process, the 17 students' professional skills and observable behavior were assessed to establish a final comparative model. The initial skills were identified from a role-playing exercise developed in class and compared with the final skills acquired after the actual experimental exercise with the companies. At the end of the process, a structured survey of 30 questions was applied. It divided and oriented toward the self-recognition of skills acquired for design management. Indeed, interviews with the business team were also carried out to evaluate the students' competences. A checklist with a dichotomous ordinal measurement scale I used as a data collection instrument. We use the Carter-Richardson statistic and the t-student to measure the reliability of the instrument. The results below show an interesting changes in the soft skills for the design manager. First, in the collaborative skill, there's no significant difference in the mean, implying that the students started to the design management course with acquired ability. This was manifested during the process through their contribution of ideas, empathetic attitude, and adaptation to the work environment. Also, in the critical and creative thinking skill, there's evidence and slight development of the skill in some students. In some groups, behaviors associate with the need to specify questions, the curiosity, or to understand the context. And in some cases, the ability to observe the problems from different perspectives and points of view. In the communication and facilitation skill, there was no significant variation before and after the experimental practice. So in the context, mastery skill developed remarkable in the end of the practice. The students presented behaviors of individual and group awareness of the impact of their decisions. They made detailed analysis of the current business context, and the most observable behavior was to maintain a global and systemic vision of the environment. It was uninteresting. The time management skill showed similarities before and after the experimental practice. There was no variation since the students presented problems in defining and not delaying a task, using systems to recognize information, and defining realistic goals. However, given the level of the students, it's a skill that requires more complex learning at higher levels. In reflection on action skill, despite not showing significant variation, the skill remains constant throughout the practice. This phenomenon happens because the product design program bases its teaching on learning by doing, which prepares the student from the first level to break down problems into parts, accept feedback, and use systematic, logical reasoning to carry out projects. Finally, Significant changes have been observed in developing design management skills. The skills most impact students were context, mastery, and reflection and on action. These results can be attributed to the immersion in a case study with a company. The focus of the activity on developing these skills, the role of the students as a guide, and the constant feedback from the business. This learning ecosystem allowed the students to participate in activities requiring more advanced skills, such as identifying patterns that affect the future, recognizing the impact of actions and decisions, break down the problems into parts, and reflecting on one's processes. Uh, in the conclusion, finally, using an active pedagogical as a teaching model requires considering professional skills from the initial approach and we can then to personalize knowledge according to the student's abilities and students' learning outcomes. The new perspective on the industry-oriented learning model suggests identify the specific roles of each model actors within the learning activities and exercises. This suggests an initial strategy for increasing the company's involvement throughout the inclusive co-creation and co-participation learning process. An innovative educational model requires permanent contact with industry since it's a more significant technological and organizational development sector, and the requirements change faster. The design manager's soft skills require permanent updates according to the company's demands. This approach ensures a higher probability of employment for the students and project professional designers. Thank you all for your attention and join us. Please do not hesitate to contact me if you need to know more about my research. I appreciate your time. Thank you.